in case, because I know Manuel's going to make all kinds of noise in the background. It's what he does. All right. And feel free, if you've got a question, just chime in. And please remind me to repeat the question to everybody else because I know they can't hear it very well. Okay, so we want to do the derivative of the tangent of x. We do know what the derivative of sine of x is, and we do know what the derivative of cosine of x is, but we don't know how to do the derivative of tan of x. Now, fortunately, there are all these identities, and so we know that tangent of x is the same thing as sine of x over cos of x. We're also going to look at these a little bit later, but we basically have all the tools we need to take the derivative of tangent of x, knowing that it's sine of x over cos of x, and knowing that's an identity. So basically, we're taking the derivative of this rational expression, sine x over cos x. And so if you like, when you're doing these things, you can, you can turn this into the product of two functions by expressing this as cos x to the exponent -1. I am just going to do the quotient rule, though, because, like I say, quotient rule's got a better song. So, song goes, bottom times the derivative of the top. Derivative of sine x is cos x, minus the top times the derivative of the bottom. The derivative of cos x is negative sine x. Oh, it's getting way over there into my identities. And where's my meter stick? Uh-oh. Can I use Hot Wheels track? I could use Hot Wheels track. Sorry, everybody. All right. And this is all over the bottom squared. Finishing the song in fine style. Here we go. Over cos squared of x. Okay. So, yes, good enough. I'm going to simplify this. So this is cos squared x plus sine squared x. And it's all over cos squared x.
How do you know it's cos squared x and not like cos x squared?
So it's kind of an order of operations thing because this means take the cosine of x and take the cosine of x and then multiply them together. So I'm multiplying cosine of x by the cosine of x. To indicate that, we put the little squared sign here on top of the cosine. But it means that, okay? It means the cosine of x squared. So you put the big brackets on. But we represent it this way. So there's a little bit of a trickiness in the way it's expressed. Johnny, I don't know if that answers the question completely, but this is some number between 0 and 1 multiplied by some number between 0 and 1, and so it's going to be those two numbers squared, rather than multiplying the x's together. All right. There's good news here, everybody, because cos squared x plus sine squared x, we learned this in grade 11, it's always equal to 1, no matter what we do. It's always equal to 1. That's the Pythagorean identity. So this is 1 over cos squared x. And if I look over here, basically, 1 over cos x is secant x, so I can convert this into a secant squared x. Okay? Not really a big deal. To be honest, I never really remember what the derivative of tangent is. I just always turn it into sine and cos, and then I do the quotient rule. So on the test, I don't know. I'm probably not even going to ask you for like the derivative of a tan function, but if I do, if you don't remember it's secant squared x, you just go back and do the quotient rule. Turn it into a ratio.
Cos squared x.
Oh, sorry, Morgan, I couldn't quite hear you.
Why wouldn't you cross out the cos squared x? Like, you know how you have one on top and one on bottom?
Yeah, so see this right here? So Morgan's question is, why can't I do that? And the answer is you really cannot, you absolutely cannot do that because you are violating laws of algebra. So future Mr. Rogers is rolling in his grave right now, but that's a really good question because that is a common error that everybody makes, okay? So let's take a look at this. You have to divide everything in the top by cosquared x. That means divide this as well as this, okay? I could break the function into two, but let me show you. So if I had 2 plus 5 over, no, let's make this 2 plus 8 over 2, okay? I just can't go like that. I can't cross those out and say that that is equal to 9. It just doesn't work because look, 2 plus 8 is 10. I have to do this operation first. And I think Maddie corrected me and said, put brackets on top there so that everybody knows it's all one thing, okay? But you can't cross those out. You have to do this operation first, and then you're going to divide by 2. And so 2 plus 8 divided by 2 is actually 5, okay? So I appreciate the question because that is something that is a very common error. And as Maddie says, that line underneath means that's actually a bracket on top, okay? So you have to do this before you do that. If you could factor a cosquared out, that would be a different story. All right. So, good question. On to the next. In spite of me rolling in my future grave. Okay. Does that make sense, Johnny? Was it followable? Maddie says, yeah. Does everybody have it? If I start to erase it, nobody's going to be mad at me. Here it goes. Because I'm going to do one derivative of one of these reciprocal functions. Okay, so let's do the derivative of secant of x. And I don't know how to do that. But I do know how to take the derivative of cosine. So I'm just going to turn it into 1 over cosine x. And I could use the quotient rule here. The derivative of the top is 0, though, and so that would be a lot of song and dance for what it's worth. So I am going to turn this into cos x to the exponent -1. And instead, I'm going to use my chain rule on there. Okay, so there's an outside function, something to the exponent -1, and there's an inside function that's cos x. So let's do the full treatment on this. The inside function is the cosine of x. And so the derivative of u with respect to x is negative sine x. And the outside function is u to the exponent -1. And so dy du is equal to the derivative of this. I'm just going to use my power rule, -1 u to the exponent -2. Now I'm ready to do my dy dx is equal to dy du times du dx. And so this is negative u to the -2 times negative sine x. These negatives are going to cancel, and this, just simplifying this a little bit, this is sine x over u squared, because that's a negative exponent there. And just remembering that u is equal to cosine of x. This becomes sine x over cos squared of x. So, you know, we've done pretty well. It's almost done. We can actually turn this into, you will actually see this written more in a slightly different form. More often you will see it in a slightly different form because this is equal to sine x over the cosine of x times 1 over cosine x. Sine x over cos x gets written as tan x. 1 over cosine x is written as secant x. So there we go. That's all there is to it. And it maybe seemed like a bit of a big song and dance because we went through all the chain rule stuff. But basically, we just took the fact that we know the derivative of sine and cos, and then we turned it into a chain rule problem and used our chain rule on it. We also did some manipulation back and forth using identities. Okay, so anyway, I think that's about it. That's the last lesson of the last unit of the calculus part of the course. So in this section, we've learned about 4 things. We learned that the derivative of e to the x is e to the x. We learned the derivative of a to the exponent x is a to the exponent x times the natural log of a. We learned that the derivative of the natural log of the natural log of x is 1 over x. And we learned the derivative of sine is cos, and the derivative of cos is negative sine, and that we can just use those to find the derivatives of everything else. That's like the last unit. Okay, I'm going to stop broadcasting now and accept all forms of criticism grudgingly.